Hello, my name is Dan Christopher. So today I'm going to present about my final year project, which is mining student opinion using text classification based on social media using machine learning. Okay, what is opinion mining? So opinion mining, basically you are taking opinions from a social media. So you have it as a data and then you pre-process it. Then you will undergo feature extraction. Then we will train and test using machine learning. And then the machine learning helps to classify the text from the opinions of an individual into positive class or negative class. Okay, so we talk about the problem background. So problem background is UTM have a problem to know the student's opinion on UTM facilities, management of UTM, and also the service that they provided to the students. So the students will give their opinion on a Facebook page about UTM management and all. And then but then some UTM authorities will not be able to clarify their students' opinion on a specific issue as students will only be comfortable to voice out their views on social media. So this will actually uh, help to know whether what's the student's problem based on the classified data, because the data will be separated into negative and positive comments. So this is the research aim. So research aim is to study the appropriate machine learning technique that classifies student opinion to text classification from social media about the service, management and facilities of UTM. So the first objective is to investigate appropriate machine learning techniques that will classify student opinion. The second one is to develop a machine learning based opinion mining model that will classify student opinion in terms of the comment of the social media about the service, management and facilities of UTM. The third one is to validate the machine learning model based on the accuracy developed. Okay, the scope is basically the data will be obtained from the students that have commented about UTM facilities, service and management on UTM official Facebook page. So the machine learning technique will mine the data from the sentences and classify it into positive review or negative review. So basically we will extract words in Bahasa Melayu and classify the text using developed machine learning model. So the research contribution is the student's opinion about the service, management and facilities of UTM able to be mined and classified to positive and negative with the help of a validated machine learning model. UTM authorities also will know about the comments outcome and will make decision for the betterment of the service. Okay, we will talk about the literature review. So this is the 5 authors that I've reviewed and studied about opinion mining, and then from this information I have started to execute the opinion mining process. So this is the methodology. So the research approach is to develop a opinion mining model to classify the comments of students in UTM to positive comments and negative comments. Then we validate the model based on the accuracy developed from the comparison between the machine learning algorithm using support vector machine and naive bias. So the naive bias will be into two types, it is multinomial naive bias and complement naive bias. And this is the proposed framework. So we will start with the review and studies, and then the data acquisition, data pre-processing, feature extraction, then creating a training model and testing model, and then classification using machine learning methods, and then the last part is data visualization. And this is the methodology. So for the methodology, we'll start with the research design to evaluate requirements, scopes, and resources. And then the second one is data acquisition to gather data from official UTM Facebook page. And the third one is data filtering and classification, which will be done using data pre-processing and feature extraction. And then classify data using multinomial naive Bayes, complement naive Bayes, and support vector machine. And the last part is data visualization. So this is the research design. Then we will start with the data acquisition. We will be doing that using by calling the data comments from official Facebook page using FacePager, and then data filtering to eliminate unnecessary data in the extracted data by using data reprocessing and using feature extraction. And the third one is data classification to classify the data into positive comments and negative comments using supervised machine learning methods. And the last part is data visualization, is to visualize the result after data classification using Microsoft Excel. So next we'll move to the implementation of methodology. So the first one is review and studies. So we'll have two domain of research, which is opinion mining and social media. So the studies on opinion mining and tasks of opinion on social media. So we'll be reviewing on supervised machine learning through an opinion mining using text classification. And the second one is data acquisition. So we will take the data from the official Facebook page, the UTM, where students commented about the service management and events. The data accepted from Facebook, which is the comments, will be classified in their specific category, so it will be easier then to filter the data. The data will be stored in a CSV file using Microsoft Excel. So we will crawl the data using FacePager, which will have the token to access the Facebook page through the FacePager, and we can call the data from the official Facebook page. And this is the example of the CSV file data that I collected, the screenshot. And this is the FacePager interface. So you can see the access token there that used to log in to the Facebook. And then we'll go to the data filtering part. The raw data will be filtered for the classifier algorithm to classify the data accurately and effectively. Normally the social media tags are very noisy and we want to clean as much as possible, so our model will understand the structure of sentence much better. The dataset will undergo this phase in order for the dataset to get ready for feature extraction and into the training model. The data was pre-processed using Malaya pre-processing. The data undergoes feature extraction using TF-IDF factorizing. So now we will talk about Malaya pre-processing. So Malaya pre-processing can replace special words into tokens to reduce dimension curse. For example, 5k will become a money word, so it will to reduce the dimension. And then Malaya can expand hashtags such as sangat, hashtag sangat sakit becomes sangat sakit, and tags for special words. For example, hashtag sangat sakit become hashtag will be the sangat sakit will be inside the hashtag. Then Malaya can expand English contractions and also translate English words to become Bahasa Malaysia words. Malaya is also able to remove postfix for a word and normalize elongated word, such as Sabah becomes Sabah, and also to perform segmentation of words using Etibai algorithm. And this is the figure of the pre-processing implementation from my code. and this is the about the feature extraction. So why we do feature extraction is to decrease the dimensionality of the dataset. The second part is to extract the important characteristics of the word. And then the third is the feasibility and efficiency of the classifier becomes better when you perform feature extraction. So for this research, we use TF idea factorizer. So the term frequency is actually how often the word appears in a document, and then the inverse document frequency is that highlights words that appears frequently across documents. So this is the meaning of how TF idea factorizer works. So TF factorizer will literally tokenize the documents and then encode new documents by learning the vocabulary and inverse document frequency. Then label encoder was used to encode the labels, which are the categories to use to classify each of the comments. So this is the implementation of TF idea factorizer in my code. Now we'll talk about the training model. So 90% of our pre-processed information is utilized for the training set, then 10% for the testing set. So we classify the testing set with the training model and compare the classified outcome. So this is the example of how we really split the data. Then next we'll go about to the classification using machine learning methods. So the first one is multinomial live bias, which is suitable for text classification and is not needed much for training set and testing. And then the second one is support vector machine. Support vector machine is actually a hyperplane that separates two classes. So based on its best performance by previous studies, that is used for classification. The third one is complement live bias, similar as multinomial live bias and suitable for imbalanced data set. And then the last part is data visualization. And then the data of positive comments and negative comments are stored and tabulated in a table form for further visualization of data. The tools used to visualize the classified data was Microsoft Excel. Then bar chart was preferred to use as a presentation of data in percentage form to show higher number of percentage and lower number of percentage in terms of negative sentiment and positive sentiment. And then this is the software requirement. So we use Face Pager, Notepad, Microsoft Excel, and then Google Colab integrated with scikit-learn. So this is the description of the software used. So you can just see about it. Then we will go to the research, design and implementation, management of the university. The results obtained from the classification algorithm is discussed and compared based on the accuracy, which will decide the opinion mining model. So this is the architecture. So we have training and prediction. So for the training we have text, then we go to layer preprocessing, then TF idea factorizer, then we feeding the features into the machine learning algorithm, and then for the prediction the same thing, and then we'll go to the classifier model, and then the classifier model will predict whether it is positive, neutral or negative. So this is the experiment design. So phase 1 is setting up the libraries, phase 2 is training and testing data, and phase 3 is output data. So we will okay, so how you set up the libraries is using Google Colab that can run through online and execute code on Google Cloud servers. So the scikit-learn machine learning library need to be installed and designed to use information from numerical and scientific Python libraries such as NumPy and SciPy. So NumPy is a numerical Python which provides structure of data and array for data retrieval. So SciPy is a scientific library for scientific computing. So Pandas is also needed, which is used as a tool for data analysis. And then Maya is also installed using pip install Maya for text pre-processing to clean the data. Then we'll go for the training and testing data. So raw data will be collected using the URL of the official UTM Facebook page. Then data will undergo pre-processing and feature extraction. And then the dataset will undergo training using three supervised machine learning algorithm, which is SVM, multinomial naive Bayes, and complement naive Bayes. The dataset will undergo testing using the testing dataset to check whether the machine learning model is able to show the expected result or not. This is how we implement the training and testing. So you can see how we import complement naive Bayes and then multinomial, and then also support vector machine. So how we will fit into the training and testing. Then this is the output data. So dataset will undergo sentiment analysis process to classify into positive comments and negative comments. And then the files containing data has been extracted, retrieved as an input file, and then undergo the sentiment analysis process using model to undergo the comparison with the input files containing positive comments and negative comments. So the process of classifying the text according to the type of sentiment is by the model reading the whole file containing the text about the specific categories. So it will show in decimal points of the value of the positive comments and negative comments. So if the positive comment is more than negative comments, so the reading will show more higher for positive. So that's how we separate the analysis. And then this is how we use to read the file for this part, to read the text containing the data of the specific categories. And then this is to predict the data, that meaning the comments, to read it so that we can obtain how many negative and positive. As you can see there, you can see in decimal points of the negative, the percentage of negative and positive that is shown in decimal points of each category. Same goes to here. And then this is the tabulation of data of all the categories. As you can see, positive comments and negative comments, and how much of positive and negative comments of each category. And then this is the parameters. So the parameters, we have precision, recall, accuracy, and F1 score. So this is how we calculate accuracy, precision, recall, and then F measure. So basically, as you see from there, you can see A, B, and C and D. So D is representing the true negative. So the meaning of true negative is the text is negative and the outcome of the classification progress is negative. And then C is false negative. So the meaning of false negative is the text is positive but the outcome of the classification process is negative. Then there's true positive for A. So true positive is the text is positive and the outcome of the classification is positive. And then false positive is for B, and then the text is negative but the outcome of the classification process is positive. So that is to represent false positive. And then this is the metric classification report for multinomial naive Bayes. As you can see, the precision, recall, F1 score, and support. And also you can see the accuracy there, which is 0.48. And then you can see how we implement the code to produce the metric classification report. And then this is for the support vector machine. It's the same accuracy obtained, which is 0.48, and you have all the precision, recall, F1 score. And the 1, 2, 3, 6, 7, 8, 9, 10, 11, 14 represents the categories of all the previous, as you saw, like all the categories in a separate file. So that is what represents 1, 2, 3, 6, 7, and 9. And then this is for the complement naive Bayes. So we have obtained about 0.65 accuracy from this complement naive bias. Then this is the data tabulated in table form of the three machine learning algorithm. You can see the accuracy, precision, and recall of three machine learning algorithm. So about complement naive bias, support estimation, and multinomial naive bias. So we can see the precision value of complement naive bias is the highest compared to support vector machine and multinomial naive bias. This is because the value of false positive for complement naive bias is lesser than SVM and multinomial naive bias. So false positive is actually taking the negative statement and making it as positive. So in this case, support vector machine and multinomial naive bias have higher false positive, meaning that they do not classify the positive statement correctly. So that is why they have the higher false positive value. So which makes the complement naive bias to have higher precision because it has lesser false positive. And then now we will compare by the recall. The recall value also shows higher in complement naive bias is because uh, both support vector machine and multinomial naive bias have higher value of false negative. So false negative is taking the positive statements and making it false. So in this case, both support vector machine and multinomial naive bias have higher false negative because they do not uh, take the negative statements and classify it properly into a correct category. So that is why they have higher value of false negative, because they are taking a true statement and putting it as a negative statement. So they do not classify the statement into a proper class. So due to the higher value of false negative and the lesser value of false negative for complement naive bias, that is why the recall value of complement naive bias is higher. And then by comparing the accuracy, uh, complement naive bias shows the highest from. Okay, now we compare about complement naive bias and multinomial naive bias. Both is naive bias, but then uh, the simple rule of naive bias is their independence rules, and also to solve the multi-class problems. But the difference between complement and multinomial is complement uh, supports the major assumption made by the multinomial naive bias. So that is why complement is a slightly better accuracy than multinomial naive bias. And then this dataset is not suitable for support vector machine because support vector machine basically have a kernel function and the data normally sits outside the boundary. So that is why support vector machine unable to classify the data into positive and negative comments because most of the data are sitting out of the boundary. And then this is the result and analysis of the sentiment analysis of each categories. So from here you can analyze about the positive and negative comments. As you can see, the highest positive comment goes to UTM events and the highest negative comments goes to UTM hostel, and then the lowest positive comments is actually goes to UTM lecturers, and then the lowest negative comments goes to UTM events as well. So from here we can analyze how many positive comments and negative comments for each category. Then we'll go to the conclusion. So the conclusion is, you can say the main objective have achieved through this research by validation on which model is the best to comparing the accuracy obtained from three supervised machine learning methods. And then the output of sentiment classification and metric classification report have been visualized clearly, showing the best machine learning suitable for this dataset. And the steps and process to produce the end result, which is the opinion mining model, have been explained clearly in methodology and experiment design. So for the future work is to build a model using better algorithms such as deep learning, also larger data set. So both of this is to achieve a better and higher accuracy than the accuracy obtained from this research. So thank you, and this is what have contributed for my final year project. Thank you.